for this channel, and hope you like my last video that was on Olama installation in our local system. And today we are gonna talk about RAG, what is RAG, how it works, and basically all the theoretical part will be here. Okay, I will be explaining every point to point, and in future also we will see all the practical implementation of RAG. So yeah, so, if you didn't see my last video that is based on running Olama into our local system, just go and check it out. It is there. Okay. So, yeah. So, today we're gonna talk about track only, and let's start. I have made a PPT just for good explanation of this topic. Okay. So, let's start. Um, so, basically, RAG is like full form of RAG is Retrieval Augmented Generation. So, what it is, let's see. So RAG means it will just retrieve something and retrieve from your knowledge base. Knowledge base is like, yeah. So I will tell you everything. LLM, normal LLM, what is do, how it works. Whenever we used to ask anything to the LLM, and it gives us response. Okay, and the LLMs are basically trained on internet data. Okay, whatever it is, ChatGPT, Claude, or whatever it is. Okay, and different kind of data, some specific target, or there will be a goal, so that LLM will work on for a specific industry only. Okay, so that LLM will be trained on some specific type of data, but not ChatGPT. ChatGPT is a universal kind of GPT that is giving like we can use in every sector, right? Each and everyone right now using ChatGPT for their own work. Either they are related from AI field or software development, or a common man just asking his queries, whatever he's thinking or whatever it is. Okay, he just go to ChatGPT or Claude and ask whatever he wants to know. Okay, and GPT just generate all the whatever user query to the GPT, and it will just give the answer, whatever it is. Okay, so what RAG do? This concept RAG is like making GPT more smarter. Okay, with your own data. Suppose you want to make a chatbot. Okay, chatbot of course chatbot, or AI system or LLM that trained LLM that can answer on your data. Your data means, suppose you are having a restaurant. Okay, and you just want to make a profile of your restaurant just by like whatever recipes are there you are using in your restaurant, or you have a YouTube channel or whatever it is. Okay, and you want to put all that recipe into your system. Okay, and there will be like like you will make it that you will store everything in either CSV or a Word format or whatever, a PowerPoint file, whatever it is. Okay, the thing is, RAG gives us a property so that we can integrate our LLM with our data only. Okay, and that LLM will respond, will be integrated with our data and respond accordingly. Okay, suppose we want any query related to our data. Okay, that will be fed to the LLM. Okay, and then LLM will give us response according to that only. Okay, so now let's start. Okay, so LLM doesn't rely only on training data. Instead, retrieve relevant external knowledge, inject into prompt, generate grounded answers. So how RAG basically works? Okay. So now we will go on like how we used to collect our data. Okay. So let's go. See, data collection is a very important part, right? I am telling you, whatever data it is. If someone wants to make his own chatbot, okay. So the thing is, ki data should be in a very proper manner, okay, so that our LM can give correct response. Not it should not hallucinate or anything. Okay, it should give like proper answer. Then only that is a perfect state of art LLM or chatbot. Okay, otherwise what it means, I mean, even a normal human being can see manually to the data and give us answers. Okay, so data collection is very important. Okay, so whenever we used to collect the data, we need to have the relevant everything relevant to the domain, created one. Okay, and structured. Okay, bad data means it will be bad data, what it calls like, it will duplicate data or noisy data, irrelevant data, or there are too many null values are there. Okay, and some wrong kind of data is there. Okay, data redundancy will be there. Okay, so yeah. So just like example, vehicle chatbot and clean space data. Like every vehicle will have some specification, and that should be very clean. Okay, if some vehicles suppose RAG doesn't know the price of any one vehicle. Okay, that price is not launched by the organization, any company, the vehicle company. So in that case also we have to just delete that whatever, or we have to give some instructions to the LLM. So LLM should give us response according to that only, but it should not give us response in a wrong way. Okay, so cleaning data is a very important part, that whenever we are making a RAG based system. Okay, noise means wrong answers only. Okay, and there are various steps, like too many steps are like removing duplicates, fix encoding issues. Okay, normalizing text, है ना, remove irrelevant fields, etc. Like, okay, so these are the parts of this data cleaning part. Okay, or pre-processing part, that we need to pre-process our data. Okay, yeah, just I gave you the example of car price. If it is none, then just remove it. Otherwise, your LM will give something else, any other price, or any incorrect price. And at that time, LM work of our LLM will fail. Okay, it is not giving a proper answer. Then why it is a LM, right? So yeah, and let's go to the next slide and we'll see. So there are different like there are different uh, components of RAGs. Okay, so first component was like data collection. Okay, then second is like data cleaning, then third one is like chunking. Okay, what chunking means? Chunking means suppose we are having a very big sentence or whatever. Okay, so it will just take the whole, it will not directly take a whole sentence at once. Rather than it will just do it will split the whole sentence into different like smaller pieces. Okay, and then it will fit to the LLM, so that LLM can get the wider view of whatever sentence, whatever a user wants to ask, whatever user is asking. Okay, so why LM context limit है ना, why chunking is important. Better semantic search also. Okay, semantic search, semantic search means whatever like similarity search, you can say. Okay, semantic search means whatever we are asking to the LLM, it should be relevant. Okay, so it should give, it should take that part of data only. Okay, suppose I'm asking about how biryani, chicken biryani or veg biryani we can cook. Okay, so it will not go for something like ki, we want, a user is asking ki, how to make potato biryani or something, egg biryani. Okay, it will go to veg biryani only or chicken biryani only. That is called semantic search. Okay, we will talk about it in like in upcoming videos also, in upcoming slides also. Okay, so yeah, there are two types of chunking. First one is fixed size chunking, and second one is semantic chunking. Okay, and goal is like each chunk should represent one idea, every chunk should represent one idea. Okay, now let's see like um, flow of RAG system, how it works. Okay, so here is the raw data, whatever raw data we have collected till now. Okay, and then we used to do pre-processing part like cleaning and formatting the data. Then we do chunking. First one is like we used to do like tokens. So tokens, what are the tokens? Each and every word is a token, each and every space is a token, whatever punctuations we are using, those are tokens. Okay, and plus overlap is also a technique. Okay, in chunking, where I will explain in future also. Okay, this while we will be doing the practical work. Okay, and then embeddings come. Okay, so embeddings are nothing, just that suppose we are having like a sentence. Okay, that sentence will be converted in numerical value. So this all like machine learning, deep learning, and this everything AI related libraries or frameworks or concepts, these all works on embeddings only. Okay, so just converting in high level language to numeric based language. So basically it is not a language. Okay, embeddings are like it is a representation of a sentence or a image. Like suppose we are talking about computer vision, what it do in computer vision, a image has pixels, and pixels have some some numeric values. Okay, so whenever like it is we are making a classifier for cat or dog classifier. Okay, so each and every image will be converted into numerics only, numeric format only. Those numeric formats will show the pixels of that image. Okay, I mean, a image contains how many pixels, and I mean, color combination of the image. Okay, then we comes to vector database, that is FAISS and ChromaDB or whatever we are Pinecone. So there are many vector databases also. Yeah. Then user query, whatever user will give query. Then again user query will be converted into like embeddings. Okay. So that this embedding and this embedding, like this is our data. This embedding is for our data only, whatever data we are having, and this embedding, user query embedding, this embedding is for user query. So I am asking about suppose chicken biryani. Okay, so both embeddings will check by something like cosine similarity. Okay, and both the vectors will be getting compare, will be get compare, and then it will give us the recipe, whatever it is. Okay, then top tier retrieval, what are the top retrievals from our knowledge base we are getting. Okay, then re-ranking, this is a very important concept we are having. Re-ranking basically ki, suppose in your knowledge base there are so many kinds of recipe of biryani. Okay, so which one is the best? Okay, what user is asking for chicken biryani. Okay, so re-ranking means our LM will take lots of it will retrieve lots of biryani recipe, then it will again re-rank what is the most important one, what the user is actually asking. Okay, so this is re-ranking. And then prompts construction, this one is very important step that is we use in our RAG based system. Okay, and whenever we are working with chatbots and all, we need to give some prompts to the, we'll talk about this also in upcoming slides. Okay, like we used to give prompts to the LLM so that it can give us output in that way only. Okay, suppose we are making a chatbot for our kitchen recipe, and so it should give us a response as a cook only. Okay, so like that chatbot is basically a cook who is giving instructions about how to cook any cuisine. Okay, so yeah, this is prompt construction. And then LLM generation. LLM generation is like your this is the last step that we used to get whatever user is asking. Then it will just generate our output. Okay, and LLM is generating output just by when it is integrated with our knowledge base, and mm, from that knowledge base it will give us output. So this is LLM generation. And then the evaluation part. Evaluation means we used to evaluate what how is our RAG based system is working, and yeah, so is it correct, giving us correct answers or not? Okay, so now let's come on chunk size. Okay, why chunk size, like this part is important for us right now. Okay, so if we will I told you what is chunk size. Chunking is suppose we are having a very big sentence. Okay, like a sentence made of 1,000 or 2,000 words. Okay, so this chunk size will if chunk size will be too small, then it will lose context. So that 2000 lines of paragraph will be converted into chunks. Chunks means smaller sentences, and that will be fit to the LLM. Okay, so two small chunks means lose context. Okay, and poor answers. matlab, It will give not a correct answer, or maybe it can hallucinate or whatever. Okay, two large chunks means irrelevant info. Okay, and token waste. Token waste. We know ki, how important this token is. Everything. Either we are using chat GPT or Cloud, we know ki we reach our token limits. Okay, each and every time. So token waste is very important. We need to consider this a very important step. Okay, it's our LM should not just whenever you user is asking, so it should not say कि हाँ, by just giving irrelevant answers, it should not say कि हाँ, your tokens are got exceeded. Okay, it should not work like this. Okay, and then this is the ideal range. Like if you are having big sentences like 1,000 or 2,000 words of sentence, then this is the ideal range, 200 to 500. Okay, general. But suppose we are having little sentences. Okay, small one, then we can just make it a small number also, like 50 or 20 or whatever it is, or 5 or 10 also. Okay, So it is not about always key we have to use this only. Okay, so yeah. And room, so the rule is ki chunk equal to meaningful plus self content. Okay, so chunking, why we use it should be meaningful and self content. Okay, and yeah, per chunk. And let's go to the next slide. What is chunk overlap? Yeah, I told you chunk overlap. So chunk overlapping means okay, for this I will give suppose do we have any big sentence here? No, we don't have. Okay, okay. Chunk overlap. Oh, let me show you. Not bad, not bad. Okay, so um, so suppose. Okay, okay. So suppose this is our a whole sentence. Suppose it is something else, but yeah. So whenever we will do chunking, it will do like this. Okay, overlapping means we are considering till here. Okay, chunk size. Okay, but what overlapping will do? See, from here to here. Okay, but in overlapping it will again do in second chunking step. It will do from here to here. Like first sentence will be also considered, but not the whole sentence. It will like half of the sentence will be considered for our next chunking. Okay, and again if we'll go for third chunking, then we'll go like this. Okay, so again second chunking is also getting like for converted in the third step also. Okay, so we are taking this third second also, half of the second chunk, and until the next chunk size. Okay, whatever chunk size we are having. Okay, so this is yeah, uh, chunk overlapping. And so examples are like engine info plus chunk 1, engine info plus chunk 2, engine plus mileage. Okay, and again if chunk 3 will be there, then again mileage plus something like how many cylinders your vehicle is having. Okay, so typical overlap is like it should be like 10 to 20%, not fully half. It can be like 10 to 20% only. Okay, I was just giving you the example like how it works. Okay, like each and every chunk will have some part of the previous chunk also. Okay, so yeah, benefits. What are the benefits of this better retrieval continuity? We'll see this. We will do like this fixed size chunking also, and then this overlap chunking overlap also. Okay, then here is it comes embedding. What is embedding? I told you, embedding means whatever chunks we are having, just convert to into numeric format. Okay, that is called embedding. So okay, so converting into vectors. This is the word that I was forgetting. Vectors. Each and every numeric value is called known as vectors. Okay, so goal, whatever, why it is important, again similarity search, so that it can give us the particular solution for a query. Okay, whatever query we are asking, it should be correct, and it should give a genuine answer, not a hallucinating answer or whatever. Okay, even a human can do it better rather than a LLM. So why we need LLM? Okay, yeah. So yeah, now we will go on vector database. So there are like FAISS and Pinecone and ChromaDB are there. Okay, so these are the vector databases. So what? So basically, it stores embedding for faster. So this is the actually search engine that whenever we will give a query to the our RAG model, it will go to the it will this vector database, this FAISS and Pinecone, these will work as a search engine. So these will basically do this cosine similarity or Euclidean distance or whatever similarity algorithm we are using there, but basically this uses cosine similarity or Euclidean distance. So this will check what user is asking, and it will just go to the knowledge base and then give us the answer according to the user query. So yeah, this is vector database. And then query understanding. Yeah, query understanding means whatever user is asking again, so that will be converted into the embeddings. Okay, uh, uh, there are few challenges also. Okay, short queries lack context. Okay, what user is asking. So solution is query expansion, and add some system prompts. We'll talk about the prompts also. Okay, yeah. So retrieval core. Okay, uh, so this is the retrieval part of the rack. Okay, so this suppose we are having a user asks any query, like I told you about the chicken biryani, okay, but it will go to the knowledge base and retrieve everything about biryani. It can be egg biryani, it can be chicken biryani, it can be fish biryani, it can be veg biryani, whatever it is, okay. But now. um uh, this k basically represents the number of results, okay. So low k means misinformation, and high k means added noises, okay. So the thing is ki our our output should be very relevant, okay, and with the low noise, okay. Low noise means and relevance means it should be correct, and it should not give us like any random stuff that we are suppose we are asking about biryani, and it is giving about something like how to about any Chinese platter or whatever, है ना, cuisine की, हाँ, this is also added there. No, you are just asking about biryani, so it should give answers about biryani only. Okay, so and this case like number of results, how many results LM is retrieving, and then we will go. But this is not the final part. Okay, then we used to do re-ranking on that key only. Okay, so whatever we are getting too many retrievals like this. Let me show you. Similar chunks, okay. We retrieved all the biryani recipe, every biryani recipe, okay. But what are the important, what is the important one, what the user is asking about veg biryani or chicken biryani or whatever it is, okay. That specific recipe, some specific recipe of biryani, okay. So in this process it will do this thing, uh, which one is important, most important one will be uh, shown to the user, okay. So yeah, this is re-ranking, where re-ranking works, okay. Just to finding the most important according to user query, okay. So there are like different re-ranking model we'll talk about in upcoming video also, cross encoders models or score or relevance, है ना. Basically we used to do this re-ranking using these two techniques, okay. So yeah, uh, example like it will again I told you na, it will just take top k matlab, I mean all the biryani recipes, but and it will re-rank if what user is asking, and your user is asking like chicken biryani or veg biryani, so it will give in that way only, okay. Then again prompt construction, very important step that one of the important component of RAG. Okay, so why it is important? Okay, so prompts basically our LLM doesn't know ki how I should give answers. Suppose we want answers in like 4 to 5 lines only. Okay, or whatever it is. Okay, so we used to give our LLM some examples. Okay, there are like 2 3 techniques for this prompt construction, like zero shot prompting. If you want our LM should be very simple, it should give whatever it is getting, or our knowledge base is like that only. Knowledge base, I'm talking about your data that you are integrating with the LM, okay. It is very simple. Then we don't do this like we will just do zero shot prompting, and we do query to the LM, and it will give response according to that. And like few short prompts are there, like we give few examples to the LLM key. You have to give us uh, uh, you have to generate our um answers in this way only, okay. You have to generate answers in some particular way, so that that is why I mean LLM here is working na, just in a proper way, not like something it should be messy or something, okay. You have to so basically this thing it basically controls the behavior of LLM, okay. Answer only using given context, okay. Yeah, clear instructions should be there, okay. So these things we are teaching to our LLM, okay. This every whatever written here, we are teaching to our LLM ki you have to respond in this way only, okay. Don't add too much noise or too much redundancy or whatever it is, okay. Wrong answers in the output. Just give me in this structure, and you are ready to go, yeah. So yeah, and last step is like generation again. So LM generation, final answer, uh, hallucination can be possible. Yeah, I told you that is why this step is important. Prompt construction, um, without prompt it will hallucinate maybe sometimes, okay. It will not get to know ki what user is asking, actually asking what I should show to him, okay. If I'm asking about something specific, it should give me some specific answers only, not something any other thing, okay. Rather than that, uh, specific one that user asked. So yeah, generate LLM is this is the generation part, how LLM will respond. Okay, so there are some risks like hallucinations, yeah, and solutions are like strict prompting again. I told you, and context grounding. Okay, we'll talk about this in practical work. Okay, and better models means better reasoning also. Okay, we have to use some better model. Those are trained on billions of parameters, so that with the better reasoning and better understanding, it can give better answers to the user. Okay, and last one is evaluation, like how it our so this is the end. Till here, your RAG is working perfectly. You have done the all the above steps. Your RAG is working perfectly. Okay, and now the evolution part comes. Okay, where we used to check key matrices, like this whatever system we chatbot we made till now, is it working perfectly or not? Okay, so like there are different ways of checking this. Okay, precision, correctness, recall, okay, and faithfulness, no hallucinations should be there. Okay, so these are the matrices, and there are like manual we can ragas is there. Okay, so this is a manual technique, and some automated evaluation is also there, like raga ragas. Okay, so it will evaluate our this rag based system key, is it working properly or not? Okay, and then yeah, so evaluation output example, like suppose we are asking about the engine power, and then it checks ki is answer from context and any extra info. Okay, is it correct or not? Okay, so yeah, I told you ragas is there, human evaluation is there. Okay, and yeah, and what common problems we used to face, like bad chunking, noisy data, poor embeddings, weak retrievals. I will tell you everything how we overcome with these like these situations, and everything, है ना? And what will happen, whatever if you'll mess with any this step, wrong answers. Okay, LM will not generate pretty much good answers to the user, and it will fail. So yeah, so this is the whole steps that involves making a RAG based system. Okay, so okay, in our next video, we will just do it practically, how it works, and each and every step we will see in our next video. Okay, so if you are like getting confused, don't get confused. Each and every step is very simple. There are 5 to 6 components are only there. Okay, so this slide maybe some like 18 pages or 19 20 pages big, but no, there are like 5 6 steps are there, and you can just make a chatbot with your own data. So there is nothing serious or complicated here, and it is very easy. Right now organizations are demanding too much for this. Okay, this skill you have to, in generative AI you have to know this RAG based concept. So we will see. Okay, this is not a very big thing. Very easy. I will show you everything in next video. Okay, so thank you so much, and if you like this video, I don't know. Okay, um, uh, I'm just new in to making this teaching related stuff. Okay, but yeah, if you like this video, please do like. Okay, and watch my next video so that you can relate all this theoretical part in with the practical one. Okay, so thank you so much. Bye bye. Love you. Peekaboo.